This is actually something that might be a little bit new for you, so I wanted to just go through it. We're going to solve it, like it says, solve it by factoring, completing square quadratic formula. First rule is you have to make sure everything is set equal to 0. So we'll do that first, and then this one does factor, so we'll just go ahead and factor that. Make it a little easier, plus, minus, less than or equal to 0. So we know that our roots are +1 and -2. So since we know that, what we're going to do is we're going to sketch a little number line here, and we're going to put that -2 and +1. Always make sure you put it so the smaller values are on the left. And it's less than or equal to, so we're going to put open circles here. So now what we're going to do is we're going to pick a test value from each part of this number line where those roots separate it. So I'm going to say for this, I'm going to test x is -3. Here, I'm going to use 0. If you have 0, use it. And then here, I'll use +2. So we're going to plug this in to see if it makes the inequality true or not. So I'll do -3 squared plus a -3, and I want to know if it's less than or equal to 2. So 9 minus 3 is 6. Is 6 less than or equal to 2? False. Okay, then I'll plug 0 in. 0 is always nice if you can use it. So 0 squared plus 0, so we get 0 less than or equal to 2, which is true. And then x is 2, so we'll plug that in. 2 squared plus 2 less than or equal to 2, so we get 4 plus 2 is 6 less than or equal to 2, false. So where is it true? It's true for this area right here. So that means that this will be our solution into this zone right here in the middle. So if I want to write the solution using set builder, I'll say x such that -2 is less than or equal to x, which is less than or equal to 1. And if I want to do interval notation, I'll do -2 to +1. All right, so for the next one, it is already set equal to 0, so that's good. We can factor that. Factors of 30 that give us 11 will be 5 and 6, both positive. And we get -5 and -6 for our two roots. So again, we're going to make that little line here. I'm going to use -6, smaller than -5. And this is sort of a pain because we have to use a fraction here. So I'm going to use x is -7 for my test point, and I'll do -5.5. And x is, I'm going to do 0. All right, so -1. So not -1, -7. -7 squared plus 11 times -7 plus 30. So we get 49 minus 77 plus 30. And that gives us 2. Is 2 greater than or equal to 0? Yes, that's true. Then I'll do -5.5, and I'll put that in a calculator. You can feel free to always do that too. All right, so so we get -1/4 greater than or equal to 0, which is false. All right, and then when I put 0 in there, I'm going to get 0 greater than or equal to 0, which is true. Okay. So our solutions this time will be here, and it's a closed circle because it's greater than or equal to, and here. Okay, those are my true spots. So for set builder, I'm going to write x such that x is less than or equal to -6, or x is greater than or equal to -5. If I want to do my interval notation, you have two different intervals that you're going to write, and then write the word or in between to show that it has to be both of those.